Pydantic AI agents accept a capabilities parameter that composes reusable units of behavior, toolsets, lifecycle hooks, instruction additions, and model settings, into a single extension point that replaces threading scattered configuration arguments through an agent constructor. Each capability subclasses AbstractCapability and overrides configuration methods like getToolset, getInstructions, getModelSettings, or lifecycle hooks such as beforeModelRequest, wrapToolExecute, and onModelRequestError, following a middleware pattern where before hooks fire in list order, after hooks fire in reverse, and wrap hooks nest around the handler callable. The following code demonstrates a custom capability that wraps the agent's toolset to log every tool call at execution time, registering itself via getWrapperToolset and intercepting execution through a WrapperToolset subclass.
Before X right arrow wrap X handler. Success right arrow after X modify result. Failure right arrow on X error. Re-raise right arrow error propagates. After X not called. Recover. After X modify recovered result.
This is the Pydantic AI capability system, a middleware pattern where capabilities compose via lifecycle hooks. Each hook point before X, wrap X, after X, on X error follows the same contract. Before X and after X are entry-exit hooks that modify inputs or outputs. Wrap X receives a handler callable and decides how to invoke it, and on X error handles failures with raise to propagate or return to recover semantics. The before X hooks fire in capability order, after X in reverse, and wrap X nests as middleware, so the first capability is outermost. The per run state isolation via for run, returning a fresh instance, is important for mutable state like request counters. Without it, a shared capability leaks state across runs. Dynamic capabilities let you resolve a capability factory at runtime from RunContext, which enables per user or per dependency behavior without instantiating the agent differently each time. Error hooks are where wrapX recovery meets afterX. If wrapX catches and returns a result, onX error fires and can further transform or suppress the error. This gives you retry flows, fallback responses, and guardrails in a single hook layer rather than scattering recovery logic across the agent. Let's break it down line by line.
Before X right arrow wrap X handler.
Passes handler to wrap X, with before X as the target. Arrow syntax suggests a transformation pipeline where before X gets wrapped by wrap X with handler as the argument.
Success right arrow after X modify result.
Maps the success state to after X, which modifies the result.
Failure right arrow on X error.
Maps the failure state to the on X error handler.
Recover after X modify recovered result.
Shows a flow relationship where a recovered result is passed to after X for modification. The whole thing is one middleware pattern. Capabilities compose via lifecycle hooks, before X fires in order, wrap X nests around the handler, after X fires in reverse, and the error path connects directly. WrapX either lets the error propagate skipping AfterX or recovers and feeds the result back through AfterX for modification. Per run state isolation via for run keeps mutable things like request counters from leaking across runs, and dynamic capabilities resolve per run from RunContext, so you get per user behavior without reinstantiating the agent. The arrow flow just names that same pipeline before X wraps into WrapX. Success exits through AfterX, failure enters on X error, and recovery loops back to AfterX. One hook layer handles guardrails, fallbacks, and retries without scattering logic.
The ModelRetry that devours AfterX still lets CTX cradle the swallowed answer.